Good day everyone, I'm Shamina Nandakumaran and together with my groupmates Tani Kumarbelo, Durkashini Pichaimutu, Loha Vashni Vijayendran and Prasina Devi Subarao, we will be presenting on today's topic, In-situ bioremediation, a sustainable approach for heavy metal removal and wastewater treatment under the supervision of Dr. Nur Afifa. To begin, I will start with my introduction. Introduction of in-situ bioremediation is a sustainable, cost-effective method for heavy metal removal and wastewater treatment at contaminated site. It utilizes the microorganism to detoxify the pollutants to bioabsorptions, bioaccumulations, and enzymatic process, which will reduce the environmental impact without evacuations. We choose this topic because it highlights an eco-friendly and cost-effectiveness method for tackling one of today's major environmental challenges, which is heavy metal contamination and wastewater pollutions. In situ bioremediation usually is a natural occurring or engineered in microorganisms directly at the contamination site. It reduces the need of the evacuations or chemical treatments. This approach not only minimizes the environmental disruptions but also promotes the sustainability by harness of the natural detoxification abilities of the microbes. And not to ignore the objectives of this presentation is because to explore the potential of in-situ bioremediation as a sustainable and cost-effective method for heavy metal removal and wastewater treatment, and also to analyze the key microbial mechanism and species involved in detoxifying heavy metals and also improving the wastewater quality.
Moving on to the methodology, I will be explaining about one of the in-situ bioremediation technique that currently being used in Malaysia, which is in palm oil mill effluent using water hyacinth. So first of all, a site is selected. So in the case study, palm oil mill effluent wastewater pond, especially in states like Selangor, Johor, and Sabah, was selected. This is because these areas are characterized by high level of chemical oxygen demand (COD) and also biochemical oxygen demand (BOD). And heavy metals production. So this makes them the area ideal for bioremediation studies. So once this is addressed, a floating constructed wetland system was implemented. So a floating system was set up in the wastewater pond and water hyacinth plants were cultivated. So these systems allows the plant to float on the surface of the water while their roots are remain submerged in the water. So this facilitates the pollutants uptake and also the microbial interaction. Water hyacinth contributes the bioremediation through three mechanisms. So the first one is phytoextraction, followed by phytodegradation, and last one is the rhizofiltration. So water hyacinth has the ability to absorb the heavy metals such as lead, plumbum, and also iron from the wastewater. So they absorb these heavy metals through their roots, and they are stored in the plant's stem or leaves. So not only that, there is also a protein called metallothioneins. So these metallothioneins helps them to bind and neutralize the metals, toxic metals, or the other toxins present in the wastewater. So this not only that, it also prevents the re-entering of the water. Not only that, water hyacinth also plays a major role in breaking the organic pollutants through the process called phytodegradation. So this happens because the roots is act as a habitat for these beneficial microbes like Pseudomonas and also Bacillus. So these bacteria helps the decomposition of organic matters present in the palm oil mill effluent through the enzymatic reactivity. So the key enzymes involved in this enzymatic activity is lipase, protease, and also amylase. So as this microbe works, they convert the complex organic compound into a simpler, non-toxic forms, and it significantly reduces the COD and BOD levels.
Continuing with the methodology, um, we start with the rhizofiltration. The rhizofiltration is a water treatment method using the plant roots to filter the contaminants and also to remove the excess nutrients. So firstly, the filtration and also the nutrient removal. The dense root of the plants which act as the natural filter, and they will trap the particles like the sediments and also the pollutants, and will absorb the nutrients like the nitrogen and also the phosphorus. And this helps prevent the eutrophication. What is eutrophication? Eutrophication is a process where the excessive nutrients lead to rapid algae growth, depleting oxygen, and also will harm the aquatic life. So for the continuing with the monitoring, so the water quality is checked weekly for key indicators. So what are the key indicators? Firstly, the COD, chemical oxygen demand, which will measure the organic pollutants. And we have the BOD, biochemical oxygen demand, which will indicate the amount of biodegradable organic matter. Then the heavy metals, toxic elements like lead, cadmium or the mercury, and nitrogen and also the phosphorus. Nitrogen and phosphorus are essential nutrients, but in excess they may cause the pollution as well. So these plants will be harvested every 30 to 60 days to prevent the accumulation of the toxins and to ensure the effectiveness as well. So what are the outcomes? The benefits is it will reduce the COD and also the BOD up to 70 to 85%, which leads to improved water quality by breaking down the organic pollutants, and heavy metal removal up to 60%, which will reduce the toxicity in water sources, and also it will be very low cost and also eco-friendly, which is natural and sustainable, and also alternative treatment to the alternative to chemical treatment as well. That's all from me.
In-situ bioremediation, naturally occurring or introduced microbes degrades pollutant directly at the contaminated site. Common microbes used are Pseudomonas purida, which help in degrades hydrocarbon, heavy metal and also pesticides, and Pseudomonas aeruginosa, which is used for oil spill degradation. Phytoremediation is an in-situ bioremediation approach that used in radioactive contaminant absorption. For example, used to absorb radioactive material from soil and water after Fukushima disaster. This method also helped in removing pharmaceutical contaminants, for instance used in constructed wetland to remove pharmaceutical residue from wastewater before it reaches natural body waters.
Alright, so next I'll continue the presentations with the microbial bioremediation significance and also challenges. So when it's come to significance, first and foremost is environmental friendly. Microbial bioremediation is environmental friendly because we don't introduce any kind of harmful chemicals or substances during this whole process. And next is reduce secondary waste. Microbial bioremediation can reduce secondary waste because we don't need to go for any additional disposals or any treatment after the process. Next is minimal site disturbance because microbial bioremediations can be done directly on the site of contaminations rather than we take the whole place of the constructions of whole place of the site for us to get this done. Alright, so next moving on to the microbial bioremediation challenges. So first and foremost is site heterogeneity. So when it comes to site heterogeneity, microbial bioremediations can face any difficulties or challenges depends on the soils because the soils can be different. For example, soil pH, soil's humidity, soil's texture and so on. So all this will actually affect the whole process. And next is limited bioavailability of contaminants because again different sites, different types of soils will have different types of contaminants. Maybe we couldn't reach the microorganism that we would like to target. Last but not least is nutrient limitations. So as you all know, microorganisms need nutrients. For an example, hydrogen, carbon, sulfur and phosphorus. But when it comes to those sites with contaminants, maybe there will be lack of nutrients or less nutrients that will be sufficient for the microorganism. Thus, this will actually hinder or stop the growth of the microorganism.
In conclusion, bioremediation is a sustainable, cost-effective, and eco-friendly solution for heavy metal removal wastewater treatment. By utilizing the microorganism to detoxify the pollutants on site, it minimizes the environmental impact, reduces the costs, and eliminates the need of evacuations. With advancement in the biotechnology, this approach continues to improve in efficiency and adaptability, making it a promising alternative for long-term environmental pollutions. There are certain recommendations. First is to optimize the microbial consortia. Enhancing the bioremediation efficiency by selecting or engineering microbial strains with high tolerance to heavy metal and pollutants. And next, to improve the environmental monitoring. Regular monitoring site conditions to ensure optimal microbial activity and effective pollutant removal. And lastly, to integrate the biotechnology to apply genetic engineering and bioaugmentation to improve the performance and adaptability of the microorganism in diverse contaminated environments. That brings us to the end of our presentation. These are the citations we have used and they have been properly stated through the presentation. That's all from us. Thank you for your time and also your attention.